So today I actually want to show you a side project I've been working on the last couple of days in my free time. And I want to go through the code and then show you in which problems I run. So as I already mentioned, I built a GraphQL backend using node.js and Apollo. And for storing the data, I'm using a Postgres database. And as my object relational map, I'm using typeorm. Now, to kind of glue the GraphQL part and the database part together, I'm using a library called typed-GraphQL. So after we saw the setup and how you can build a basic GraphQL server, I want to walk through some problems I've encountered. So there are 5 problems I've listed here, and then I'll show you how I solved them. So just to give you the context, and I want to show you the application I've built. It's for a fitness studio, and you can see here the fitness courses they offer. So for example, today at 9 a.m. there was this yoga course, and we've subscribed to this course, and now there are other courses where we can subscribe or unsubscribe to. So we can see here on the right side by this bar that this is a fully paginated list where we can scroll up and down. Then we also can click on the detail page and, for example, write the comment and explore those. Now, the way I've built this is, we can see this here. So the basic structure is I have an entity folder, and here I have all my entities. So each file represents a table in my database. Then I have some middleware and my GraphQL resolvers. So these are actually the handlers which go out to the database, fetch the data, and return those to the requesting user. And then I have some helper methods for mailing and so on, but that's not so important for this talk. And then I have the main file, the index.js file, where I start my server. So and here we can see that the first thing I'm doing, I create my database connection, and I'm loading my entities. So let's just explore how such an entity looks. So here we have, for example, the access token, which is a very simple entity. We see that this whole typeorm thing is class-based and uses decorators. So here with this entity decorator, we are telling typeorm, okay, this is a table we want to have in our database. And then we have some fields here, and we annotate them so that the typeorm knows how this field which type the column should have. Now we can also see an example here of how the relations look in typeorm. So here, an access token belongs to one user and gets deleted when the user gets deleted. Now let's jump back to our index file. Here we can see that as a next step, we're initializing our server. And then we will come back to this part later, but here we are binding our CLS context. And here we are already almost finished. In this step, we are building our schema. So in GraphQL, you have actually 2 parts. You have a schema, which define the types the backend offers. And then you have the resolvers, which I already mentioned, go out to the database, get the data from some other data source, and return it. So the resolvers act upon these types. Yeah, and with the schema, we can then create our Apollo server. With the schema, then we are also having some hooks, like the authentication hook, and some plugins. We also will take a look at the plugins later on. And then we can bind this Apollo server to our Express server and start it. Now, when you are creating an Apollo server, you also have this playground, which you can disable for production, but for development it's nice to use, so you can play around with your backend. And here we also have this schema part, where we can see which types and which endpoint our backend gives us. So if we scroll down here, for example, we can see our mutations. So here we can log in a user, create the comment, delete the user, and so on. And then we have our queries. So this is, for example, the query which I used to get the paginated list on the web app working. And we also have, for example, this me query, which returns the user who is performing the request. And here we can see the type. So on the me query, I, as a client, can access some properties from this user type. And this user type is described on here. So these are all the properties we can request from the user type. These are simple types like an email, which is a string, but we also can include subscriptions. So we also can fetch, for example, the trainings which we've been or to which we subscribed. Now, how does this look in the code? Actually, the types which we want to be queryable are also annotated on the class here. So we didn't see this on the access token because the access token shouldn't be queryable, but here on this user entity, we can see we are creating a table, and we can see the annotations we already saw on the access token, but now we also have our decorators which come in from the TypeGraphql library. And so here we're telling the TypeGraphql backend, okay, we have here an object, and this object has some types which should be queryable. For example, the ID, the email, and the name. So that's why we see those properties here, back here in our schema. And for example, the password does not have the field decorator, and that's why it's not popping up here. Now, the way we get the data from our backend is by writing resolvers. So here on this user resolver, for example, we can see it's a class annotated with the resolver class, which also comes in from this TypeGraphql library. So we can see this here. And then on this class, we have all our queries and mutations which are related to the user. So here, for example, we can see this me query I've been talking about. And we're getting an argument named context, and based on this, we can return the user which is currently performing the request. So back here in our playground, we can now close the schema. And I've already have this query here. So that's the me query. And we can see here which types we can fetch. So I'm now requesting those 4 properties. And if I hit play, we're now getting back exactly those 4 properties we've been asking for. And yeah, this is how we can set up our queries. And for the mutations, it's very similar. For example, here we have a mutation to create the user. And this mutation takes in an argument, a payload. And this payload is further described with the TypeGraphql library again. And I'm also making use of a class validator. So here I say, okay, in order to create the user, I'm expecting an email and a name and a password in the payload. And I also can do some validation. So for the email field, I want to have it that it has a min length and a max length, and it should have the typical symbols for an email in it. All right, so that's basically how you can set up a GraphQL server with some queries and with some mutations. Now, if we take a look back here, we saw that we have a few problems. The first one is a rather simple problem and is not related to GraphQL. So if we take a look at our trainings query here, we can, we can fetch a list of trainings. Now, in this example, I've fetched 5 trainings. And now we as a client could do write a malicious query by, for example, requesting 5 million of the trainings or so on. If the server really would start to process it, we would probably get a problem. Now, in this case, I'm getting an error back that we reached a maximum. And the way I solve this with this stack here is if we take a look at the trainings resolver. So this is the query I've just executed, and here we can see the two arguments, offset and limit. They are an object, and this is the type definition here. And if I jump to this type definition, I say, okay, for the offset, it's okay to be an integer, but for the limit, I want it to be of type pagination limit. And this pagination limit is a custom scalar type. So in GraphQL, you have some basic types like the object type, the array type, and some simple types like string, integer, float, and so on, and Boolean, I guess. And you can use these types to create your own custom types. And this is what I did here, and I say, okay, maximum of 100 is allowed. Otherwise, the backend should raise an error. Oops. Okay, so now another problem which arose and which can be hard to track is a graph traversal attack. So if we take a look back at our playground and the me query, we saw that we can't query the password field. Now let's say for some reason the user should be able to see its own hash password, but not the hash password from some different user. Now a naive approach would be to jump back over to our user resolver, to our user entity. And let's add the field decorator to this password. I'm here in the wrong window. I was wondering why the server did not restart, but it actually did. So the server is still starting. Okay, no, it took a few seconds. So if I reload this tab here now, I should be able to query the password as well. And if I perform this query, I'm getting back the password. But if I jump over to this user query, I can now access the password of each user. And that's not what I want. So I need a way to do authorization, not only based on the endpoint, but also on the property layer. And the problem now is that on this user entity, I don't have access to the context. I don't know which user is performing the request. And one way to solve this is to use a library called the continuation local storage. So if we jump back to our index file, I'm using this library here, CLS, which I import from this library, and then I create a namespace. And now I can use this namespace as a kind of key value store. And if I scroll down here on my authentication hook, which is executed each time a request comes in, I try to look up a user. If there is a header the client sent along where the BROS token is stored, and if that's the case, I'm setting an entry to this namespace. So the key here is a user, that's just a constant, and sorry for jumping around that much, and the value is the ID of the user. So I now have the ID of the user stored in a namespace, and if I go back to my user resolver, or to my user entity, I can scroll down here, and here I added a field called my password. And in this field, I try to look up the user ID of this namespace. And then once I got this current user ID, I can check if the row which I fetch from the password, if the ID is the same as the ID from the current user. And if that's the case, then I set the password, this password, so this field above here, to this my password variable. Otherwise, I set it to an empty string. I could also set it to null or throw an error or handling it in some other way. Now on this user's query, if I request my password, I get back my password on this entity because that's me, but on this other user here, I just get an empty string. So that's how one could solve this problem. Now if we jump back to our problem slide here, we see that the next problem is called n+1 problem. Now an n+1 problem typically occurs when you have an entity, a parent entity, and it has many child entities, so one-to-many association. Now if you fetch the main entity and then you fetch each child entity separately, you get a lot of queries. I'm not having this exact problem, but mine is very similar. So if we jump back over to this trainings query and execute it again, let's put the limit back down to 5. We see that this kind of works, but yeah, we are fetching the title, the comment count, and the subscription count. Now, however, there's a problem with that, and if we go, I just need to enable logging of the database statements and wait till the server restarts. We will see that, okay, we are fetching a list of trainings, in this example 5, that's one query, but to get the comment count, we are performing one query for each training we fetch. So let's perform this query again. Now it goes. So we'll see above here, we are fetching the trainings. We see here the UIDs, the 5 we fetch. And then we have 1, 2, 3, 4, 5 comment count queries. And that does not scale. And the problem for this is because on our training entity, we have here this comment count, and this goes out with a separate query to get the comment for the current training. Now, there's a problem, and one way to get around this problem is by using a library called the data loader. This is a library which is available in different languages because this problem occurs in other contexts as well. And I use this library to solve this problem for the subscription count. So here we also have the subscription count, how many people are subscribed to this training. And before I used the data loader, it was implemented the same way. Now I can't go into the details of the data loader because this would be a talk on its own, but it gives us the possibility to write a function where we get an array of all IDs. And that really helps us because now what we can do is we write a query which fetches all subscriptions at once. And then it does some grouping so that we know, okay, which subscription belongs to which training. And as we can see down here, we're only doing one query for all subscriptions instead of n queries. So we are reducing the n+1 problem to a 1+1 problem. All right, so with this library, we have been able to get around this issue. Now the next thing we have is we can add query cost analysis to specify if we want to allow this query in our backend. Because with the freedom we give to the client, there arises some problems. For example, if we take a look at this training query here, it's a big query, and like no one is stopping the client from writing this query or also bigger queries. And what we see here is that on the trainings we can fetch subscriptions, and on the subscription we can fetch a user. And from the user we can fetch the trainings again. So we're getting in a loop, and therefore we could create an endless long query. And if the query is big enough and sent to the client, it would bring our backend down. Now in this case, we're rejecting the query. Now before I show you how this is done, I just want to talk about another option, how we could prevent this. We could prevent this by depth limiting. So we could say, okay, we only allow queries with a depth of 5 or 6, and all other queries are rejected. However, there's another query which could bring our server down, like this one. Here we're fetching the trainings, which is not too bad, but then we are copying this query, and here we have the same query again, just with an alias before it. And you can like copy this thousands of times and then send it off to the backend. And there the def limiting option wouldn't bring us much. Now, one other option would be to count the characters and say, okay, if the query is bigger than 4,000 characters, for example, reject it. But the solution I implemented is to count the properties and calculate a weight of these properties. So if we go back into our index file and scroll down here to the Apollo server, here we have query complexity. The query complexity hook, and here I do some setup, and then I'm using the simple estimator to calculate the weight of this query. Now what the simple estimator does, and there are other estimators out there if you need them, it calculates one weight for each property we fetch. So if we go back to our user, let's say for this query, we are fetching the me property, which is one weight, and then we're fetching 1, 2, 3, 4, 5 other properties. So this query has a total weight of 6. And now if we take a look back at our index file, each query which has a weight greater than 50 gets rejected. So this is why why those two queries got rejected. Sorry, those two queries. Yeah. Yeah. So that's basically it. However, we can customize it a bit. So if we jump back to any entity and we would say, okay, fetching the name is like more easier than fetching the subscriptions. So we could jump in here to the subscriptions and pass in an options object where we say, okay, the complexity of the subscription should be set to 10. Now, if the client is requesting the subscriptions, it automatically counts a weight of 10 for this property. So we could further customize this. And with this approach, we can prevent these harmful attacks on our server. Okay, so the last thing I wanted to talk about is data loading. So if we go back to our playground and jump over to this query, now this query looks fine, but when we execute it, we get an error. And this shouldn't happen. Now if we go back to our trainings resolver, we can see here this query, and we see here that we are generating, that we're writing this query manually, and that we added some relations to it. Now, while the type allows us to write this query, we actually don't have the subscriptions on the user. So we're only including the user, but we are not adding the subscriptions on the user. So what's missing here is the user.subscriptions. So with this, the query would work. But now, of course, we would only optimize this query for one request. So what we actually want is, for example, this function here can be called with 4 arguments, and one of these is the info argument. And in the info argument, we can parse the ASD so that we have the information with how the query looks like. And based on this, we could dynamically write our SQL statement. Now, I did a bit of research on the internet, and for TypeORM and this stack, there's one library out there. But yeah, it's kind of working, but sometimes also not that good. So I've added it in another branch, and I want to show it. So we can see here I've commented out the query we've just seen before. And now we can see here that I'm using a library. And this library expects the entity I want to load. And it also expects the info object. So now here I'm specifying the info object, which has the information how the query looks like. And with this info object, the library is able to create the SQL statement on the fly. So this has two advantages. One, we can create our queries like we want in depth, and it will work. And secondly, we are not going out to fetch all attributes, but only the attributes which the client requested. Now if we jump over to our playground, now this query, it should work. Yep, and it worked because the query was created by this library on the fly based on the input we sent. All right. So now we've been able to go through these 5 issues, and I hope there are not any more issues in this backend because I want to finish the project, but that brings me to the end of my presentation. So thank you.